Hello guys, welcome to another video in the series of coding. We are going to do the last problem of the weekly contest called maximum number of robots within budget. Let's try to understand what is the problem. So they have given us something called budget. We have to never exceed budget. And what you have to do is you have to take a note of this quantity. So the total cost is calculated as the maximum of charge times plus k times sum of running cost. Okay, so let us try to understand what they are saying. So you have to try to pick up as many robots as you can pick, right? So this is the aim of the question. You have to pick up maximum robots. First thing. Second thing, you have to pick up robots continuously only. So you cannot pick one robot here, one robot here, one robot here. This is not allowed. You have to pick them continuously only. And you have to try to pick as many robots as you can, right? So let's take an example. Let's say we decide to pick the first 3 robots. Then what will happen? So we are picking 3 robots, right? So 3 times the cost. What is the total cost? 2 plus 1 plus 3. That is 6, right? 2 plus 1 is 3, 3 plus 3 is 6. So this is 6. 3 times the running cost plus the maximum value from the charge times. So here the maximum is 6. So this is 18 plus 6, which is equal to 24. Now 24 is less than 25. This is within our budget. So this is allowed. So you can pick 3 robots. 3 can be one of the answers. But is it the maximum answer? We are not yet sure. Maybe there is some answer with picking 4 robots also. We don't know, but this was just an example. Okay, let's try. What if we try to pick these 4 robots? What is the maximum value of charge times? So for charge times, you have to take the maximum value. Here it is 6, right? So 6 plus, so if you are picking these 4 robots, you have to take the sum of the running cost. So 1 plus 3 is 4, 4 plus 4 is 8, 8 plus 5 is 13, and 13 times 4. What will be this? This will be 52. 52 plus 6 is equal to 58. So that will be lot greater than our budget. So this is not allowed. You cannot pick these 4 robots. It will go beyond your budget, right? So what is the way to solve this problem? So first of all, it is given sub array, right? It is continuous. So whenever you see a continuous sub array, most of the times you have to apply the sliding window technique, because if you apply the sliding window technique, you can easily pick a continuous sub array. So we can understand that the problem is a sliding window problem, right? Now this is the first part. We will apply the sliding window technique and we will try to find out. For the sum, we can easily apply a sliding window technique, right? Let's say you want the sum of these elements, okay? So we will start a sliding window from here. We will start these elements, okay? So let's say these elements, by calculating the total, it is exceeding our budget. So let me take one example. What is the running cost of these elements? 4 plus 3 is 7, 7 plus 1 is 8, 8 plus 2 is 10, 10 into 4 is 40, 40 plus the maximum here is 46. So it is exceeding our budget. So what we can do, we can try to remove the last element. So using the sliding window and 2-pointer technique, whenever we are exceeding budget, we will maintain 2 pointers, right? So 1 pointer will be at the end and 1 pointer will be at the start. So we can try to remove this element. If still it is exceeding our budget, we will remove this element and we will continue with the window forward. So this is the sliding window technique. We will see a full example, but just telling like this technique. So now that is fine, but what about calculating the maximum element? So you have to also calculate the maximum. Now let's see how to find the maximum value in the most optimal time. So this question is already another question. It is called sliding window maximum. I will attach a link of this video in description, but let's discuss it again here also if you have not done this question. So I have to find the maximum element, right, in a subarray. Okay, let's say I have a subarray of length 3. In all subarrays of length 3, if somebody is telling me to find the maximum element, so in the first subarray of length 3, the maximum is 6. In the next subarray of length 3, the maximum is 6. In the next subarray of length 3, the maximum is 4. So for any given length, if I have to find the maximum value, how can I do it in the most optimal way? Is using a data structure called DQ. Now what is a DQ data structure? See, a queue is only one way, right? In a queue, it's only one way because you can only access the front element. But in a DQ, you can access both the front and the back element. You can access both the elements, okay? So let's try to understand how to find out the maximum element for every subarray that we are taking. So let us see this. So first we see the element 3. So I put the element 3 in my DQ. I have a DQ. Okay. Next I see the element 6. Now think this. So if I have seen 6, 6 is obviously greater than 3, right? So I can remove 3 and I can put 6 in my DQ, because what I am trying to find is the maximum element. So maximum element will always be stored at the front. So I can pop 3 now from the front and I can put 6 because I want the maximum element. So I will pop 3 from the DQ and I will store the element 6. Okay. Now let's continue. Now we see the next element. The next element is 1. Now see, what I am going to do is I cannot consider just ignoring this element, because in later future cases, see, 6 will not always be the answer. 6 is the answer for this subarray, right? But consider this subarray. Consider this subarray. When we take future subarrays, it is possible that 6 is not even there, right? In the future subarrays, I will not even have the element 6, right? Because I need to see all the subarrays. So in the future subarrays, if I don't have 6, maybe 1 can be my answer. So I cannot just ignore 1. So for the future subarrays, I should also store 1. So I see 1 here. So I am going to put it behind 6. Because when 6 will not be the answer, later on 1 will come at the front. So for the future cases, 1 can be a possible answer. So for that, I need to store it behind 6. So whenever we see elements, we are not going to ignore them. We are going to put them at the back side, right? But now why did we ignore 3? Why did we pop 3? Because 3 was claiming to be, like 3 was occurring before 6, right? So what happened is, if I store it like this, it is useless, right? For the future cases, it is never possible that 3 is the answer, because if 6 is a greater element occurring after 3, so even in the future subarrays, what will happen is 6 will be my answer. 3 will not be my answer. So whenever an element is there in the front, what I can do, I can remove it if I see an element greater than it later, right? So when I see 6 in the future subarrays, 6 will be my answer. 3 will never be an answer. So what is the use of storing 3 unnecessarily? But in the future cases, why am I storing 1? Because in the future cases, I may have subarrays when I don't have 6, right? So later on elements, so whichever elements are occurring later on, I need to keep a store of them. But whichever elements are previously gone, in future they will anyway never be the answer. So I can remove this element. So this is a concept which is a little tricky to understand, but once we understand, this is very helpful, because a lot of problems can be based on this. Okay, so what I'm going to do now, I have seen my length was equal to 3, right? So now I saw 3 elements. So 3 out of 3, 6 and 1, the element which is at the topmost will be my answer. So 6 is the maximum element value. So 6 is my answer for the first subarray. Okay, now let's calculate the answer for the next subarray. So for the first subarray of length 3, I have found my answer and the maximum element is 6. Okay, now let us see the second subarray. Now this is the second subarray. So what is happening in the second subarray is, we are adding a new element and we are removing a previous element. Okay, so we are adding 3. So what we are going to do now, we see 3. Whenever we add elements, we add them from the back side, and whenever we remove elements, we remove them from the front side. Okay, so now we have to add 3. We will add it from the back side, but see what is happening, already 1 is there. So since I found an element greater, I can pop this 1 and I can store 3. 3 is a better answer than 1, right? So what happens, I can pop it and I can store here. DQ should always be in descending order, because the topmost element is going to be our answer all the times. Okay, so that's it. Now let's continue. And by the way, 3 was anyway not there in the DQ. If it was there, we would have removed it, but previously 3 was not there. We just added a new 3 here. Okay, so we can just continue. So now for this subarray, what is the answer? The front element is still the answer. So for the second subarray also, the answer is 6. The maximum element is 6. Okay, now let's continue again. Now we have the next subarray. Let me just erase this arrow. Okay. And let's consider the last subarray. So this is the last subarray. Now in this subarray, when you are considering these 3 elements, see what is happening. First your 6 has gone, 6 has removed, right? So you should remove it from the DQ also, because 6 is no more a part of the subarray which you are considering. You will get wrong answer if you use this. So from the front we need to remove. That's why we are using a DQ data structure, so that we can add and remove elements as per our convenience from both the back side and front side, right? We need to do both the operations, so only we are using DQ. So 6 is no more a part, we will remove it. Now we have only one element, okay, 3. But in the new subarray we are also using a element 4, right? See, we have already processed these elements, but we are seeing a new element for the first time, 4, in the subarray. So what we will do, we will try to find its position in the DQ. Now whenever we add elements, we add them from the back side, but you see 3 is already there. Now 3 is useless, because for the future cases 4, if we have got a better answer, we will store it. So now 4 is at the front, so after processing 4 is the frontmost element, so 4 is the maximum element. So this is the maximum element for each of the 3 subarrays. So this we can use easily to find out the maximum element in order of n time and order of n space. That is why we are going to use this, okay? So now let us come back to our question. So we have a question. Let me copy this question. So this is our actual question. Let me copy it and paste it here. So now how do we solve this question? Once we know this, now it is very simple, okay? We are going to see the entire dry run of this, so that it is very clear what we are actually trying to do. So we have to find out the maximum number of robots that we can collect, right? And the robots that we are going to collect is going to be continuous only. So from continuous itself we understood that we are going to use sliding window, okay? And now to find out the maximum element, now they have asked us to find the maximum element. So from that we understood we have to use the DQ data structure to do it in order of n time and order of n space, okay? So we are going to use these concepts. Now let's see the entire dry run. So we are going to start from the very first, right? So let me start from I equal to 0. So we are going to take the first element. So what is the total cost now? Let me write total cost variable below. What is the total cost? What is the running cost now? It is simply 2 into 1, right? There is only one element which we have taken, and the charge time is equal to 3. So maximum element is only one element, so that is 3. So the total cost is 5. 5 is obviously less than our budget 25. So in our answer we can store 1. At least we have found one element, right? Okay, now let's continue. For the next time what will happen, let's try picking the next element. Let's move our I pointer. I will be equal to 1. Okay, now we are trying to pick these two elements. Now what is the total running cost? 2 plus 1 is equal to 3. And how many elements we have picked? 2. So this is the number of elements which we have picked, and this is the sum of the cost. 2 plus 1 is equal to 3, and we have picked 2 elements. So 3 into 2, that's why I have written, okay? Plus the maximum among these two. What is the maximum? The maximum is 6, right? So remember, in this array we have to take the maximum, in this array you have to take the sum, okay? Let's continue. So 3 into 2 is 6, 6 plus 6 is equal to 12. Now obviously 12 is also less than 25, right? So that means this is also a valid answer. So now we can increase our answer, at least 2 elements. So at least 2 robots we can pick, okay? So now let's still continue and let's try to get even better answer. So now we will go forward to I equal to 2. Let's try to pick 3 robots and see if we are able to pick them. What is the sum of the cost? 2 plus 1 is 3, 3 plus 3 is 6. How many elements do we have? We have 3 elements. What is the maximum among these 3 values? Maximum is 6. 6 into 3 is 18, 18 plus 6 is 24. Now obviously 24 is also less than 25, which is our budget. So in this case your answer can be changed and answer will become equal to 3. You are allowed to pick 3 robots, right? Okay, now let us continue. Now it will become interesting. Let us see. So now we are going to I equal to 3. Okay, fourth element. So now what is the sum of the cost? 2 plus 1 plus 3 plus 4. 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is equal to 10. How many elements we have? 4. 10 into 4 is 40. And what is the maximum of these 4 elements? How are we, by the way, finding the maximum of the 4 elements? We are going to use that DQ logic, right? DQ concept to find the maximum of the 4 elements, okay? So as of now, I did not include it because we are only seeing a simple example, but later on we will see using DQ also. Okay, we will see the entire dry run. So 10 into 4 is 40. 40 plus maximum is 6. 46. Now you see 46 is greater than budget. So in this case, this is not acceptable. You cannot pick 4 robots. So what you are going to do, from where are you going to subtract the robot? You are going to subtract the robot from the beginning. Okay, so that you are going to continue with this subarray. Okay, from the beginning. So we can have a j pointer. So initially j was equal to 0. Now j can be changed and j can be equal to 1. That means you are going to consider these 3 elements only. You are going to remove the first element and try to get a better answer. So what is the sum of the cost now? 1 plus 3 plus 4. What is it? That is equal to 8. How many elements we have? 3. And what is the maximum among these 3 elements? It is equal to 6. So 24 plus 6 is equal to 30. Now 30 is also greater than 25. 30 is still greater than budget. That means this is also unacceptable. That means you have to remove this element also. So we are going to remove the second element and we will move our j pointer. By removing element, what we are doing, simply we are moving our j pointer, right? J pointer tells us where we are currently. So now j is equal to 2. That means we have this. Okay, so this will be, now let's calculate what is the cost. 3 plus 4, this is 3 plus 4, this is equal to 7. How many elements we have? 2 elements only. And what is the maximum among these 2 elements? It is 3, right? The value of this element is 3. 14 plus 3 is equal to 17. 17 is our total cost. 17 is less than budget, which is equal to 25. So it's amazing. This is allowed. We can pick these 2 robots. It will not exceed our budget, but the answer is already 3, right? So if we pick these 2 elements, we will get an answer of 2 only, but answer is already 3. So you need not change answer. But this is also a possible valid case. But you need not change answer because already you have a better answer. Okay, so now we can move our I pointer forward because now we have a valid answer. So now I will move my I pointer forward. Okay, so I will come here, I will come at 4. So now we have these 3 elements that we are picking. So what is the total cost? 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is equal to 12. 12 into 3 elements plus maximum value is 4. This is the maximum value. 36 plus 4, 40. 40 is obviously exceeding 25. Not possible. You cannot pick these 3 robots. So what we are going to do, we are going to remove from the back side. Okay, so obviously we will remove these elements, right? And now we have 2 elements. Let's consider what is the cost. 4 plus 5 is equal to 9. 9 into 2 plus maximum value is equal to 4. 18 plus 4 is equal to 22. 22 is within budget. 22 is less than 25, right? So less than equal to is also allowed. So within budget is allowed. Anyway, 22 is less than 25. So this is acceptable. But if you pick these 2 elements, you will only get an answer of 2. But answer is already 3, right? So you need not change the answer. And now when you move your I pointer, I will go to I equal to 5 and you can just exit. Okay, so the time and space complexity will be order of n. Now what we will do, we have understood what we are doing. Now we will see how along with DQ we are going to solve this problem. Okay, I did not introduce DQ before because I didn't want to complicate. Now once we have gone through the entire dry run, now we will do the dry run along with DQ to see the entire approach. Okay, so let's again start. What are we doing? We are starting from I equal to 0, right? So we will keep a variable, we can keep a variable sum. What is the sum? Sum is currently equal to 2. Okay, we can keep a variable total cost. What is the total cost? Total cost is equal to 2 into 1 plus maximum value is equal to 3. How are we going to get maximum? We are going to declare a DQ so that in order of n you can get maximum every time, right? So for the entire array you can easily get the maximum value for any sub array. So in the DQ currently there is only 1 element and I am going to push 3 in the DQ, right? And what will be this will be at the front. Okay, so so if we see the maximum value from the DQ, we can just do DQ dot front, right? If we do DQ dot front function, it will give us a maximum value. So it is equal to 3. Okay, so what is the total cost? Total cost as of now is equal to 5. 5 is obviously less than budget, so our answer will be equal to 1 because we have picked 1 element. Awesome. So till now everything is hopefully clear. Now let's continue. Now we will change our I pointer. So I will go to I equal to 1. That means we are going to pick these 2 robots. So what is the total cost? So sum can just be increased simply, right? Sum you can just increase simply. So sum plus will equal to 1. Okay, so for increasing sum, very simple code, just take this element. So initially sum was 2, so 2 plus 1 will become equal to 3. So after you pick this robot, the sum will become equal to 3. What will be the total cost? Okay, for finding total cost, first you have to find the maximum element. So how you can find that? So first of all, you see 6, right? 6 is the current element. So in the DQ, when we see 6, there is 3 is useless. Whenever you see 6, 3 becomes useless, okay, because 6 is greater than 3. So how can 3 occupy the throne? 3 cannot occupy the throne. The throne will go to 6. So 6 should sit at the front because 6 is greater than 3 and you have to find the maximum element. So you can just remove 3 and you can put 6 in the DQ. Now let's calculate the total cost. Okay, what is the maximum element? Get the frontmost element. This is the maximum element. And what is the sum? Sum is equal to 3. How many elements you have picked? How you can get? Easily you can get. Where is your I pointer? I is equal to 1. And where is your j pointer? J is equal to 2. That means you have picked 2 elements. I minus j plus 1 will give you the number of elements that you have picked, right? I is the end pointer, j is the start pointer. So I minus j plus 1 will give you the number of elements. In our case, we have 2 elements. We can easily see that in code we can do I minus j plus 1. That will give you the number of elements. So that is 2. 3 into 2 is 6. 6 plus 6 is equal to 12. Now we will compare if 12 is less than equal to 25. Obviously it is. So we can change our answer. 2 elements are allowed. Okay. Now let us continue. Okay, let's continue. So next time, let's continue. We are going to change our I pointer. So I will come equal to 2. So your sum was initially 3. 3 plus 3. The new sum will become equal to 6. Okay. So now among these 3 elements you have to find the maximum. Okay. So by the way, in the DQ what will happen? You see a element 1, right? You see a element 1 now. So what you are going to do, you are going to push it in the DQ, because see, whenever you are seeing an element afterwards, you cannot ignore it, because in the future sub-arrays, maybe 1 can be an answer, right? 1 can be contributing factor. What will happen when 6 is gone? You have to consider for future also. So you cannot just ignore 1. You can just push it at the back. So you will push 1 in the DQ at the back. 1 will remain back. Okay. Now let's continue. What is the sum? Sum is 6. How many elements you have? How can you calculate? I minus j plus 1. So you have 3 elements. Easily you can see these are the 3 elements that we have. We have 3 elements. So 6 into 3 plus maximum. Maximum you can get from the front of the DQ. So 18 plus 6 is equal to 24. Okay. Now 24 is less than equal to 25. Obviously. So we can increase our answer. Answer will become equal to 3. Okay. Now let's continue again. Now hopefully it is getting clearer. Let's quickly finish this so that we can go forward to coding. Now we will go to I equal to 3. Now when we see I equal to 3, we will first of all change our sum. Sum will become equal to 6 plus 4, which is equal to 10, right? We have added a new robot, so our sum has become equal to 10. Okay, now let's find the total cost. How can we find the total cost? Finding the total cost is very simple. One component of total cost is sum into number of elements that you have. How many elements? You have 4 elements. Okay. Now I have to find the maximum value. For finding the maximum value, first of all, till now what we are doing, we are just we are just not removing any elements. Till now we have just taken all the 4 elements. So 3 is there in the 3 is the current element in charge times array. Where will you add it? You will add it in the DQ. Okay, you cannot ignore 3 because maybe in future cases 3 can be your answer, right? So you cannot ignore it. So you will push it in the backside. So in the backside, when you are trying to push, already 1 is sitting. Now since 1 is sitting already, this 1 is useless, right? 1 is useless. Why is 1 useless? Because once 3 comes, 1 becomes useless. See, DQ should always have elements in decreasing order only. You need to get maximum elements. Now what is the use of 1 if you have seen 3, right? So from the back side you can just remove 1 and you can put 3. So let me remove 1 and let me put 3 here. So this is our current DQ. Okay. Now what is the maximum element? Maximum is still the frontmost element. It is equal to 6 only. So what is the total cost? 40 plus 6. 46 is the total cost. Now 46 is greater than 25. 25 is our budget. We cannot pick 4 robots. Since we cannot pick 4 robots, what we have to do? We cannot change our answer. This is not allowed. we have to remove elements. Okay, so we have to remove elements. How are you able to remove elements? We can only remove elements from this side, right? So we will remove this element. We will move our j pointer. J will become equal to j equal to 1. So if you are removing element, what will happen? Your sum will also change. So your sum, which is currently 10, what you can do, sum minus is equal to whatever is this array, right? Running cost of j. Okay, so wherever your j was there, that sum you can remove. So sum will change from 10. From 10 you have to remove this element. What is this? This is 2, right? So you are removing this. So remove 2. So sum will become equal to 8. Okay, and you are also removing this element if it is there. If it is there in the front of the DQ, right? If it will be there in the front of the DQ, then you will remove it. Now 3 is not there in the front of the DQ, 6 is there. So you need not worry about this. Okay, so you are removing this element and j will come here. J is equal to 1. Now let's calculate the total cost for which elements? For these 3 elements. Okay, for these 3 elements, let's try to calculate the total cost. What is the sum? Sum is equal to 8. And what is the number of elements? Number of elements is equal to 3. How you can get that? I minus j plus 1. I is equal to 3, j is equal to 1. So 3 minus 1 plus 1 is equal to 3. There are 3 elements. There are 3 robots that you have picked. Plus the maximum element. Maximum is still the frontmost element, which is equal to 6. 8 into 3 is 24. 24 plus 6 is equal to 30. Okay, so 30 is greater than 25. Still not acceptable. Still not acceptable. That means you still have to remove elements. Not acceptable. Okay, so remove this element. By removing this element, you are changing the sum. What is the element? 1. So remove 1. 8 minus 1 is equal to 7. Move your j pointer. Where will j go? Okay, j will become equal to 2. Let me write it here. I know it's become very small and maybe very messy. So let's move j here. J will become equal to 2. Okay, now this element is 6 at j equal to, okay, at the previous j, that is at j equal to 1, which you removed, you had the element 6 in charge times array. Maybe it's not visible because it's very small. Let me zoom it and show. So the element that you had is 6. Now 6 is the front element, but you have to remove this, right? Because with this element you are getting a wrong answer. You are exceeding the budget. So you have to remove this. So if it is present in the front of the DQ, remove it. Okay, so remove it. We don't have any option. Unfortunately, we have to remove our element because it is exceeding our limit. So now both front and back are here only. Okay, pointing to the same element. Okay, doesn't matter. So now this is our array. We have only 2 elements. Okay, we have only 2 elements. And what is the sum? Sum is equal to 7. We have 2 elements. And what is the maximum? Get it from the DQ. Maximum is equal to 3. 14 plus 3 is equal to 17. Now 17 is less than 25, right? 17 is less than 25. So 17 is less than 25 is acceptable. It is within budget. So this is valid. Okay, this is valid. You can pick 2 elements. But what is the use of picking 2 elements? Already your answer is equal to 3, right? So there is no use of picking less number of robots. We want the maximum robot. So let us just continue. Okay, so finally we are going to continue our processes. Okay, these elements are removed. We will move our I. Okay, let us move our I. So I will come at I equal to 4. What was the sum? Sum was 7. So now for new element, sum will become added. Sum will become equal to 12 because the new element is 5, right? So 7 plus 5 is equal to 12. So the sum is 12. And now, by the way, you are seeing a new element in charge times also. What is the new element? The new element is 4. Okay, new element is 4. So what will 4 do? 4 will come and sit on the throne because in the DQ you have 3. 3 is less than 4, right? So since 3 is less than 4, you will dethrone 3 and you will sit here and 4 will come here. Okay, so this element is maximum. So what is the total cost? Maximum is 4 plus sum is equal to 12 and the number of elements you have is 3. 36 plus 4 is equal to 40. Now 40 is greater than 25, right? 40 is greater than 25. This is not acceptable. This cannot be acceptable. It is exceeding the budget. So you cannot pick these elements. So what you have to do? You have to start removing the elements. So how are we going to remove elements? We are going to remove the last element. So we remove 3. So the sum becomes 12 minus 3 equal to 9, right? And we will check for the element 1. Now 1 does not exist in the DQ. So anyway, it does not exist. So if it does not exist, we need not do anything in the DQ. Okay, now what is the sum? Sum is equal to 9. How many elements you have? Okay, these 3 elements are removed. You have only 2 elements, right? I have to move j also. J is equal to 3. You have 2 elements, okay, because I is equal to 4, j is equal to 1. So I minus j plus 1, this gives you the number of elements. 4 minus 3 plus 1, that is equal to 2, right? So you have 2 elements in your current subarray. This plus the maximum value you get from the DQ, it's equal to 18 plus 4 is equal to 22. So 22 is less than equal to 25. This is acceptable. But you are getting only 2 elements. Already your answer is equal to 3. So you need not change answer, okay? And now you can continue. Next time you move, I will become equal to 5. It is useless. So that's it. So what is your answer? Final answer was equal to 3. That's it, okay? Now let us write the code for it. So same as whatever we discussed, very simple. Actually, writing the code is simpler once we understand the logic. So for int I equal to 0, I less than charge times dot size I plus plus. I is the pointer which is ahead of j. So we need one more pointer which we can call as j. In our example, we use 2 pointers I and j, right? Okay, so now we need one variable which we are taking, which we were calling as sum. So what is sum? Sum will always be equal to whatever value, sum you are calculating from the running cost, right? So running cost of I. So sum will always keep increasing if you are taking the current element, okay? If your total sum exceeds budget, then only you will decrease the sum. Okay, so now let's consider, let's go forward. So this is our sum. Now we have to give the condition check. How many elements are you checking? I minus, okay, let me take another variable, total cost, so that it's better. Let's not make it messy. Let's write another variable, long total cost. Okay, now what is the value of total cost? Sum into I minus j plus 1 plus you will get the topmost element from the DQ. So DQ dot front. Now we have not yet declared a DQ, so we will need to declare it. So DQ int DQ. So the front element of the DQ will give you the maximum element. Okay. Now what are we storing in the DQ? We are going to store charge times, element from the charge times, right? From this vector, whatever is the maximum element we are storing in the DQ. Okay. So here we will have to store them in the DQ. So what you can do, you can give DQ dot push, okay, DQ dot push back charge times of I. Okay, so in the DQ you are going to push these elements. That's what we are seeing in the logic. But see, this element will be pushed, but before pushing, this element can also dethrone other elements, right? Okay, let me take one example so that it is much more clearer. Okay, let me take this example itself. So we have this array, right? This is the charge times. So initially in the DQ, let me write the DQ here. Let's say this is our DQ. So initially when we see the element 3, we are going to push it in the DQ, right? Awesome. Okay. Now next time when we see the element 6, what are we doing? If we see 6, 3 is useless, right? Because later we saw 6, so 6 will be the answer for future cases. 3 will never be the answer because 6 we saw and 6 is greater than 3, right? Now 6 is greater than 3, so 6 will come and dethrone 3. Okay, it will remove 3 and it will sit there. So this process also we have to do. So what we have to do, we have to take a while loop. It will dethrone how many other elements are before it. Okay, let me take one more example. Let's say 1 was also there before it, right? So then what it would, or let's say 5 was there. Let me take this example. Okay, now let's consider this from the very beginning. So what will happen? First you will push 5 in the DQ. Now you are going to see 3. So what you are going to do? You are going to push 3 at the back of the DQ. Now when you see 6, what will happen? 6 will come and dethrone both of the elements. So 6 will remove 3, 6 will remove 5, and 6 will sit in the DQ as the king of the DQ. Okay, because 6, if 6 is present, 5 and 3 can never be the answers. Okay, so this is what is happening here. So we have to give a while condition. While, see, if the back element of the DQ, if it is lesser than your current element, right? In our example, see, what were the elements in the DQ? Let's take this example. If 5 and 3 are present in the DQ, they are both less than charge times of I. Okay, so this says 5. Okay, for first, what is the backmost element? 3. 3 is less than 6. So if 3 is less than 6, what you have to do? You have to just remove it from the DQ. So DQ dot pop back. So because of this, you have to remove it from the DQ. So when you remove this from the DQ, what you will see? Now you will see 5. So 5 is also less than 6. 5 is less than 6. Okay, 5 is less than 6. So remove 5 also. So this while loop is completed. Now you can push the element 6. 6 is the king of the DQ because 6 is the maximum element. So this is the while loop that you have to give. Okay, now you need to check one important condition here. DQ should not be empty. If DQ is empty, this will give an error, right? You cannot pop elements if they are not empty, right? So they DQ should have some elements, then only you need to give this line. Okay, okay, now this is done. Now we have to just check if total cost is less than equal to budget, then it is fine. If this is there, then it is fine, right? But if total cost exceeds budget, then what you are going to do? You have to remove elements, because you can never have total cost greater than budget. If total cost is greater than budget, you have to remove elements. And from where are you going to remove elements? By removing elements, you have to move the J pointer, right? You have to increase the J pointer and remove the elements. So first of all, from the sum you will remove the elements, right? So sum was, when you were adding elements, you were adding this, right? Let me just copy this line here. This time you will give sum minus is equal to running cost of J, because J is the pointer which is behind, I is the pointer which is front. So just the reverse of this line. Earlier you were adding, now here you are removing elements. And also you will check if DQ dot front is equal to the jth element. So charge times of J. If this is also there, the jth element you have to remove, right? J is, you are removing the jth element, the element at the jth pointer, pointing by the jth pointer, you are removing that element. So if it was there in the DQ, you have to remove it. So DQ dot pop front. Okay, we will remove it. Okay, this is done. Now you can again calculate the total cost. Total cost will be same as this line. Okay, now you will keep doing this while, not if condition, it's while total cost is greater than budget, you can keep removing elements. Okay, that's it. And after this is done, total cost will always be less than equal to budget. Whenever this loop exits, total cost will be less than equal to budget. So you can check answer. Answer is equal to maximum of answer comma I minus j plus 1, because that is the number of robots that you are picking. So initially I can give answer equal to 0, and now from here I can return answer. Okay, hopefully this should work. Let us, okay, your answer is 5 but expected answer is equal to 3. Let us see what we have done wrong. Okay, the thing we have done wrong is we have never incremented our J pointer. That is the problem, right? So here after you do this, you also have to increment your J pointer. Okay, now let's run the code and see if it's working. Okay, it's working fine. Let's submit and see. Oh, there is some runtime error. Okay, integer overflow. Okay, we are getting an integer overflow here. So let me write the sum as long sum. Hopefully this will work. Let's submit and see. There's some compilation error. Oh, it is long sum. Okay, let's submit and see again. It's accepted. Thank you for being patient and listening.